Coming up in this tutorial, I will show you how to create a 2D camera system in DirectX 9. This tutorial uses the Sprite Movement Tutorial 11 as the base, so go and check the description below to get the sample of Tutorial 11 before continuing on the tutorial. Hey, Nathan here, welcome back to another DirectX 9 video. And in this video, I want to discuss a 2D camera system. It's going to be a very basic implementation. It's going to be a camera that will follow the player if you choose to by pressing the F key on the keyboard. And if you want to unfollow the player, you just hit U on the keyboard and it will unfollow. If it's not following anything, it will default to the center point of the world. And if you do follow the player, it will obviously move with the player. Okay, so let's get started. The first thing we want to do is create a CameraH file. So I'm going to expand the Solution Explorer here, right-click Header Files, go to Add New Item, and it's going to be a header file. And I'm going to call this Camera. So it's going to be CameraH. Now I'm going to use the if-ndef style of include guards instead of the pragma ones. And then end if at the bottom there. Okay. So if ndef CameraH, so if it's not defined, it will define it like this. The first thing we want to do is we want to include a include file that includes header, that includes mathematical operations for trigonometry, sine, cosine. And we want to do this for building the view matrix. So we're going to pound include and angle bracket DirectX math.h closed angle bracket. So we're going to include the DirectX math file. Then we want to include the game sprite, because we want the camera to have the option to follow a game sprite. In order to do that, we need to have a reference to game sprite. Next, we want to just say class graphics device here. And the reason we're doing this is so that the camera class knows about the graphics device class. The camera class will eventually know that the graphics device exists because we will compile everything and link everything. But at the compile time, it will not know it exists. So we need to have that there before we can use it. All right, class camera. So this is going to be a camera class. A few public functions, no fields at this time. So just functions, constructor and destructor. So constructors and destructor. All right. So camera, opening, closing parentheses. It's going to have an int width, int height, float angle, direct x colon xm float 3 scale factors. And the destructor tilde camera a parameterless function there. Okay. Next is game functions. We're going to have a void update. We're going to be able to update the camera because if our player moves, we want the camera to move. Void follow. We want to have the ability to follow a game object. So game sprite star following. So that's a pointer to a game sprite. Void unfollow. We want the ability to unfollow any object we are currently following. Bool. is following constant. It's going to return a constant bool value. Void set transform graphics device star G device, and we're going to use constant for that. All right, next is our private fields. So we're going to have a float angle, direct x, xm float 3 scale factors. I'm going to scroll down a little bit there. The next 3 things are going to be matrices. D3DX matrix, orthographic matrix, D3DX matrix, identity matrix, and D3DX matrix, view matrix. Next, the game sprite. We are currently following, if we are following anything. And then int width and int height. Okay. So that is our camera.h file. Next thing I want to implement is the camera.cpp file. So let's go into our source files and go to add new item, C++ file, and it's going to be camera. I'm going to move the Solution Explorer out, and let's go ahead and get working on this. So we're going to include the camera that we just made, and we're going to include the graphics device. So we're going to include camera and graphics device. Camera, the constructor. As you saw right there, I just tabbed and I used ReSharper and that automatically filled it. But you want camera, camera, opening parentheses, int width, int height, float angle, direct x, xm float 3 scale factors. So I'm going to set this arrow width is equal to width. This arrow height is equal to height. This arrow angle is equal to angle. This arrow scale factors is equal to scale factors. And I'm going to create the orthographic matrix and the identity matrix right away. So D3DX matrix ortho LH, the left-handed orthographics matrix, ampersand orthographics matrix, width, comma, negative height, comma 0.0f, comma 1.0f. So the reason we're using negative height here is because if it's positive height, our view will be flipped. So if we press the up arrow key, our sprite will actually move down. So that's why we're using negative height, so it's the correct orientation. Next thing, let's create the identity matrix. D3DX matrix identity. Ampersand identity matrix. It's a very simple one. Now the destructor is just going to be blank. So just leave that blank. Void camera update. Now the update, we're going to set int camera x is equal to this width divided by 2. Comma, camera y is equal to this height divided by 2. So we're going to initially set the camera x and camera y to the center point of the screen. However, if we are following this arrow and if the object we are following has been initialized, if this arrow following arrow is initialized, we are going to reset our camera X and camera Y. Camera X is equal to this arrow following arrow position dot X. Camera Y is equal to this arrow following arrow position dot Y. And that's complaining that position is not accessible. We will fix that in a few minutes. All right, the next thing we want to build is the view matrix. So this arrow view matrix is equal to D3DX matrix, all uppercase, opening and closing parentheses, and inside those parentheses, let's build this matrix. So this is going to be the actual matrix of the final product. What you can do is multiply one matrix by another matrix by another matrix to get this result. I just did that mathematically and wrote down what's needed for each component. So this is the first row. First column, first row. Scale factors dot X times cosine angle. First row, second column. Scale factors dot X times sine angle, comma 0, comma 0. All right, so that was the first row. This is the second row now. Negative scale factors dot Y times sine angle, comma scale factors dot Y times cosine angle, comma 0, comma 0. This is the third row now. 0, comma 0, comma scale factors dot Z, comma 0. This is the last line now. Negative camera X times scale factors dot X times cosine angle plus camera Y times scale factors dot Y times sine angle. All right, that was the first column. This is the second column of the last row. Negative camera X times scale factors dot Y times sine angle minus camera Y times scale factors dot Y times cosine angle, comma 0, comma 1. That is the last line of the matrix. And then put a semicolon after the D3DX matrix closing parentheses. Okay, so what is this? The way that this works is you have a transformation matrix, a rotation on the z-axis matrix, and a scale matrix. And what this is the product of the transformation matrix times the scale matrix. And then that result times the rotation matrix. That will give you this result here. So if you're not sure how that works, check out my matrix video game mathematics video, and it will show you a little bit of math involved with matrices and transformations and that kind of thing. But we get the transformation matrix and then we multiply that by the scale matrix, and then we take that result and multiply it by the rotation matrix on the z-axis. And that will give us this result here. I just did that mathematically and wrote down the formula for this. Alright, so that is it for the update function. Next is the follow. Void camera follow. So we're going to follow a game sprite. So this arrow following is equal to following. Alright. So this arrow following is equal to following. Next is unfollow. So void camera : unfollow. This arrow following is equal to null PTR, null pointer. Bool camera : is following constant. Return this arrow following is not equal to null PTR, null pointer. Alright, the last function we want to implement is the set transform function. Void camera : set transform. Open parentheses, graphics device, star, G device, closing parentheses, constant. So it's going to be a pointer to the graphics device. So G device, arrow, device, arrow, set transform. So we're going to do three things here. We're going to set the transform of the projection, set the transform of the world, and set transform of the view. So the first thing we want to do is set the transform on the projection. D3 DTS underscore projection, comma. For the projection matrix, we're going to use the orthographic matrix we created. Orthographic matrix. All right, G device, arrow, device, arrow, set transform, D3 DTS underscore world, comma. The world is going to be the identity matrix, and G device, arrow, set transform, D3 DTS underscore view. Our view matrix is going to be our view matrix. Alright, so that is the camera class. Next we need to modify the game sprite class. So let's go to the gamesprite.h. Gamesprite.h. And let's adjust the position private attribute. Move that from private to public. Alright. Now, let's go to gamesprite.cpp, and let's change this around a little bit. So I'm going to close that, go to gamesprite.cpp. Okay. So in the constructor, that takes float x position, float y position, and float speed. Right after we set position z, let's set speed is equal to s. Let's just rearrange this. So speed is equal to s, and let's set the velocity dot x is equal to 0, velocity dot y is equal to 0, and velocity dot z is equal to 0. So we're just setting the velocity to 0, color, and then initialized. Yep. Okay. Alright, so let's scroll down to handle input. VK up, down, left, and right. That's all good. If movement vector.x is not 0, that's fine. Alright, one more thing we need to implement in the draw function here. D3DX Sprite underscore object space is needed for the camera to work. So we're going to use a bitwise OR here. We have a sprite begin. We want it to perform alpha blending, but we also want to use this here. So we're going to use a bitwise OR so we can combine those two functionalities. So it's going to both do alpha blend and object space. And object space is needed for the camera to work. All right, so that is the game sprite. Now let's look at the game header file. Close that out. Game header. Collapse that. I'm going to include the camera up here. Pound include CameraH. I'm going to adjust the initialize function. Takes a handle to the window, comma, int width, int height. And then the private attributes, I'm going to set camera, star camera. Pointer to the camera. And then just so we know that the camera's working, I'm going to create another game sprite here for a background sprite. It's going to be a background image, and it's going to be a sprite, so it has a position and stuff like that. I just want to see how the camera works. Because if we're following the player, it's just going to be a blue background. But now that we have a background image, we can see it. We can see the image change, so we know we're actually moving. Int width and int height. The width and height of our game window as well. So that is game.h. Now let's look at game.cpp and game.cpp. And collapse that even more. Okay. So the first thing, we need to fix initialize because that's broken now. Int width, int height. And then after the G device is set up, we need to set up the camera. Camera is equal to new camera, open parentheses, width, height, 0, comma, direct, x, colon, xm float 3, open, closing parentheses, and inside those parentheses is going to be 1.0f, comma, 1.0f, comma, 1.0f. We're just going to scale everything by 1. So that creates the camera. Before we create the player, let's create the background. So background is equal to new game sprite. It's going to be at 0, 0 with the speed of 0. If not background arrow initialize G device arrow device capital D and G device, so G device arrow device, comma, the name of your background image. Look in the description and I will be giving you the assets you need to load in, both the player and the background. The background is going to be bubbles dash bg2.png. And the width and height of that image is 1280 and 720. So if that did not initialize correctly, we will return false. If it did, we will continue, and let's go to the update function here. All right, inside this update function, if get async key state vk underscore escape. If we press the escape key, let's go ahead and quit the game. So post quit message 0. If the camera exists, there's a few a couple more button presses we want to work on. If you press the F key, you're going to follow the player object. If it is currently not following an object. If it is currently following an object, nothing will happen. If you press the U key, if you are currently following something, you will unfollow it. Otherwise, nothing will happen. So if get async key state 70. 70 is the V key value for F. So if F was pressed, if not, camera arrow is following. If the camera is not following something, camera arrow follow the player object. All right. So that's if F was pressed. Now we need to perform logic if U was pressed. If get async key state, that is 85. 85 is the V key value for U. So if U was pressed, if camera arrow is following, if you're currently following something, camera unfollow. Okay. Once all that's done, camera arrow update. All right, now if player, yeah, that's fine. Draw. Okay. So we clear it, giving it a background color. Sorry, I'm dealing with a sore throat, so I'm still taking breaks to drink some water. If, after we call G device arrow begin, if camera arrow set transform G device semicolon. So if our camera exists, we will set the transform, and that should take care of that. Now, if our background exists, and background arrow is initialized, we will draw our background. Background arrow draw. Game time. And in our Destructor, we have two new pointers we need to deal with. If camera, delete camera, camera is equal to null PTR. You could do 0 if you want, or null pointer. That makes it more obvious that you are setting it to null pointer. Otherwise, this kind of looks like, is it integer 0, or it's just more obvious. If background, we're going to delete background and set background is equal to null PTR. Now, just to be consistent, I'm going to change all these zeros to null pointers on the 3 following lines there. Okay, so that is it for the game.cpp. Now let's look at the main.cpp. Main.cpp. And the only two things we're going to change here are the names. This is going to be a 2D camera and 2D camera sample. 2D camera sample. And in the initialize, we're just going to set the width and height of our window here. Okay. So, cross our fingers, press F5. Hopefully we have everything done. Images are loaded. If you need to get the images, look at the description, and you'll see the images. As you see the yellowish background, that's the image that we loaded. That's the bubbles background, and that's its own sprite. And then our player, our spaceship, is its own sprite as well. If I press up, it moves up. If I press down, it moves down. If I press left or right, it moves in the right direction. Now, let's go back to the camera.cpp. And remember when we created the orthographic matrix, LH, and I said negative height is needed so it's not flipped? Change that to positive height, and let's see what happens. If I press the up arrow key, it moves down. If I press down, it moves up. Left and right is still the same. So our view is flipped vertically. So up is now down and down is now up. We do not want that to happen. So set that to negative height so it's flipped the right way, where up is up and down is down. Okay. Now I'm going to move around and then I'm going to press F. And F is going to be pressed right now. So now the center point of the camera is now fixed to my player. And we know the camera's working because we can see the background image move and our actual sprite is staying at the center. If I press U, it'll go back to the center, default position, center of our game window. And then if I press F at the bottom right, it follows our game object. The reason I didn't leave this the same as what we had it before is because, if I move left or right here, you don't see that anything happens. That's why I created a background image, so you know it's actually moving. You'd unfollow. Alright, so that is it for the 2D camera system. If you're not sure how the matrices work, go ahead and check out my video game mathematics series and look at my matrix video for that. I might have a follow-up on that and actually discuss the actual math involved to get this. That might be a follow-up if people have more questions on that. Otherwise, it should be pretty easy to understand. If not, I will create that follow-up video. But basically, you have a transformation matrix, and then you have a rotation on the z-axis matrix, and then you have a scale matrix. And what you want to do is multiply the transformation matrix times the scale matrix, and then that product times the rotation on the z-axis. Okay. So there's a lot of applications for this kind of thing, especially when you follow. Let's say you're moving along and all of a sudden there's an explosion, or maybe it's a turn-based game and you're fighting. You perform your action, the other player performs their action, and all of a sudden there's an explosion. Maybe you want to change the way that the follow works. Maybe you don't want it to be an instantaneous follow where you go to that position. Like here, if I move to the bottom right of the screen, and if I hit F, it immediately jumps to that position, and it immediately jumps back. So maybe if you want to set the camera to go to some kind of an explosion, you want it to move to that location, not like instantaneous. Now you're seeing the explosion, but you want it to the camera to change from your position to the explosion's position over time. So it takes about a second, so you can see where the explosion is in the world. So it's not an instantaneous back and forth. It'll be a slow transition over time. And a lot of games do that. You can just adjust the follow logic there, and you can be set. Okay, so that is it for this video. I hope you enjoyed it, and I'll see you next time.